Hello, in this video, we will talk about Bayes formula and show example to make you understand Bayes formula well. So this is Bayes formula. And if we look at the numerator, so this is BI, then the probability of BI given BI and the probability of A, then times together. So this is called the likelihood. And the new denominator is the odd likelihood plus together. So this is the for each BI probability times the probability of A given BI. So I for n, which means, for example, we have different situation of B. Then we consider each kind of B, then times the probability of A given B. A is another event, and A and B are correlated. Then the left side is the probability of BI given A is occurred. So A is like additional information. So for example, here PBI, we call this prior probability. So why we call this prior? Prior means former or previous, right? So beforehand. So because we have no additional information, then we have only knowledge of BI using probability of BI. But when we have information of A, then we can use these times together divided by odd probability of B times A given BI. Then this is called total probability. So this is called posterior because we have got additional information A given B. So this is written as probability of BI given A. So this is Bayes formula from prior probability to the posterior probability, given we have information of A. So next we show example, and this example correlated to the insurance company because people working in the insurance company may focus on the probability of accident prone person and the probability of not accident prone person. So we know here generally about 30% of the population is accident prone. Then, so if you randomly select a person, you have no other information, you only know maybe he is 30% of the probability to be accident prone, right? Because we have no other information, no other particular information. So we will use this general representation of the probability for the population who is accident prone. So this is like a prior probability. And we have know that if this person is accident prone, then he will have about 0.4 probability in the next year will have an accident. But if the person is not accident prone, then he will have only 0.2 probability to have an accident during the next year, right? So this is some additional information. Then what we want to know is if we have seen this person has an accident within a year. So if we do see that this is occur and this person has an accident during the next year, what we want to know is the probability that he is accident prone. So this is like posterior probability because we have additional information that this person has accident in the next year. So this is the like a prior probability if we do not know that this person has occurred accident or not. Then we will use general representation of the population probability that he is only 30% he is accident prone. Then if we have seen that he has occurred accident in the next year, then we will know what is the probability that he is accident prone. So this is a typical Bayes example, right? Because we want to know the posterior probability after we have got additional information. So the solution is, first we will calculate what is probability of occurring and accident for the total probability. Because if the person is accident prone, he will have probability to accident, right? But if the person is not accident prone, we use AC here. If he is not accident prone, he will have also probability to the accident, right? Because if he is probability, if for the general population, a person is 0.3 probability to be accident prone. And if that, he will have 0.4 probability to have accident in the next year. But if this person from the population is not accident prone, we know he has about 0.7 in the total population, not accident prone. And if he is that person, then he will have the probability of accident is 0.2. So we times these two cases together and sum together, we'll get 0.26. So what does this mean? This means the general population for the total probability of accident occurred is 0.26 because we divided the population into two groups. One is accident prone and one is not accident prone. This is prior information, right? Prior information. So up to this stage, we do not know a real person has occurred accident or not. In this level, what we can do is calculate the general probability of a person will have occurred accident in the next year. So this is the total probability for the A1. And the PA and the PCAC is a person, general person will be accident prone or not accident prone if we have no other information, right? So, but what we are interested in is if we got additional information like that person has occurred and accident in the next year, what is the probability of he is accident prone? So this is the posterior probability. Actually is what we want to know in this problem, right? So first we calculate the total probability of accident occurred, right? Then in the next page, we will show how to calculate the probability of this particular person is accident prone if he is actually having an accident in the next year. So because now we know that he has occurred accident in the next year, then we can use Bayes' formula. The denominator is the total probability of accident occurred, what we have calculated in the previous page, right? Then the numerator is the prior information of a person is accident prone, then times the probability of accident occurred given he is accident prone, right? So times together, then divided by this total probability, and the result is 0.4615. So what this means? This means because if we have no additional personal information in this case, we only know that 0.3, 30% of the people in this population are accident prone. So if we randomly choose a person, what we can do, we know is he is generally maybe 30% of the probability he is accident prone. But now we know he actually has and at least one accident in the next year. So from this additional information, we know the posterior probability of he is accident prone given this accident occurred is 0.4615. So you know this probability is significantly larger than the prior probability of a general person who is accident prone, right? So this is a typical Bayes formula in application. Thanks for watching.